Hi, I'm Dr. Padilla. Here we talk about all things data visualization, and today we are covering continuous color scales in Vega-Lite. There are some interesting considerations that have to do with perception that we will discuss today, and I'll show you how to make a simple stripe plot and change the color scales with that. So we'll talk about sequential scales, diverging, circular scales, multi-hue, rainbow, and custom scales in this tutorial. Now, the data set we are actually using is this abnormal temperature data set that I have on my GitHub repository. Here's the citation for this. So you'll want to first go ahead and load Vega-Lite and then connect to this data set. Okay, so once you've done that, we are going to start by making a simple stripe plot. So we'll do VL mark, and the type of mark we're going to use is a tick. And then we're going to specify the size of these ticks, otherwise they'd be quite small. And I'm also going to set the thickness of the ticks as well. This will set the width of these individual bands. Then we want to specify the data that we're working with, and we've named this AB temp. Then we'll add an encoding to this as we do, and we'll specify the X and make that a year of this data set and set it to year. And then the color will be the other main part. So we'll specify VL color, and that will be a quantitative field, and that is abnormal temperature. Temperature underscore anomaly is what it's actually in the data set. And then after that, all we need is a render. Okay, we get this plot here. What I'm going to do now is make it taller. So I'm going to specify the height to be 200 to match the size that we specified up here, but the plot isn't actually showing it just yet. And I'm going to, while I'm at it, I'm going to make the width to be 700. And I'm going to spell height correctly. Oh, and I'm going to spell size correctly. There we go. And thickness also correctly. Okay. All right, so we have this stripe plot here. One thing that I want to point out when we're talking about scale is, as we've discussed in previous videos, this interesting thing happens where our perception of an individual color is influenced by the adjacent colors. So if we had a scale or a visualization here where there was absolutely no spaces in between these tick marks, your perception of this light gray would be different if it had light colors surrounding it or dark colors surrounding it. So for this reason, I'm going to leave a little white in between all of these. That doesn't fully fix everything, but it's going to try to mitigate some of those issues. The other thing I want to point out is by default, we get a white background. You could also use a black background, and again, that will change the perception of the viewer. I'm going to copy this code over because it's quite a lot, but what it's specifying here is background black, and then I'm making all of the text options white with all of these different variables. And this is what it would look like here. And again, your perception of these colors is going to be influenced by the background colors, because now all of the separating bars are white. Imagine we had a situation where we had, thinner bars. Notice that the whole overall aesthetic perception of this is that the values are darker than if they were wider, because we actually get to see more of the individual color. So it could be the case that someone's perception in this case of the actual value, their ability to read off this value, would be different than in this case. This is really tricky unless you're going to do an experimental study to determine the impact of all of these. My general guidance is to go with your intuitions a bit. Try to actually read off the values to ensure that at least you can attempt to read this correctly. For example, try to find what is the meaning of this individual here. Can you find it on the scale? And then is there anything you can do to this visualization to enhance the ability to do that? We could, for example, make this a bit wider, and then it should be easier to find some of these individual values. Still not the best, but ultimately you need to think about what is the goal of what you want your viewer to do. In this type of visualization, it is really just showing temperature change, and we don't necessarily need people to read off the individual value, but if you did, a consideration might be to add a tooltip, for example, so they don't have to look at this exactly and be able to find this individual information. Maybe they could just use a tooltip and be given the individual value. Okay, I'm going to take away the black background. Okay, so let's look at some different defaults that we have available to us. This is a continuous color scale here. There are other continuous options that I'll add down here that we can choose from. Okay, so essentially we have this sequential continuous, and it's this blues, but we can change it very easily to greens. What we'd do is add a scale to the color, and we would add a scheme to it, as these are predefined schemes, and we could change this to purple purples, for example. This would change it all to purples. So you have the ability to select any of these different defaults that are available, and I encourage you to take a look at the Vega-Lite documentation to really see a full set. We could try a few out. We can try grays here. Turns to gray. Interesting. Okay. Not that terribly exciting. This is a sequential version, and basically what it is indicating is it is showing us a scale that goes from one value linearly to another value. And what you want to do is when you're deciding what type of color scale to use, you want to look at your data and determine if that is sincerely appropriate. What we actually have going on here is we have negative numbers to 0 and then positive numbers to describe temperature abnormality. This is linear. These values are linear in themselves, but what we actually want to emphasize is the difference between the negative values and the positive values to convey that we're seeing more of these high temperature abnormalities in later years. So one of the things we might consider doing is not using this sequential version, but trying some different types of techniques. So here's a sequential multi-hue that we could try, and you can literally just paste over these different defaults and take a look at what they appear to look like. This one goes from yellow to green to blue. This is starting to kind of highlight the differences between this inherently different nature of this data set. Maybe we try yellow orange. Okay, maybe that's getting a little bit more at what we want to talk about in terms of these high temperatures. That's looking a little bit more intuitive. Now, what you might be inclined to do, and what you see people do a lot of in scientific publications, is to use one of these types of color maps where you're representing your data in a rainbow. So let's take a look at what that one might look like. Okay, so here we have a rainbow color scale here, and I would be willing to wager that 80% of scientific publications use this color scale, in part because it's the default, but there are a lot of things wrong with this. In particular, especially for this, the individual named colors don't map naturally onto any of our values. There's really no reason why these negative numbers, negative temperature abnormalities, should be purple and positive ones should be blue, and there's certainly no reason why we have an orange and green step in the middle. That doesn't make a lot of sense here. It does look very scientific and kind of flashy. So this is really a situation where you actually do see people doing this kind of thing, where you add the black background to it and, get on the cover of Nature because this is beautiful and flashy and it's attention grabbing. Some of the main issues is that it's not conveying the inherent dichotomy effectively. And this is, of course, for our data, but also for most types of data that in some ways is continuous, but this doesn't convey continuous information. We actually see it in buckets or bins. So when I'm looking at this, what I see is purple, orange, yellow, greenish, blue. I don't see this continuous scale. I see these separate individual types of clusters that are not indicative of our underlying data. So it gives us a categorical perception of the data, even though our data is continuous. That's really what all rainbows do. And that will happen when you use any two types of colors. People will group or think that the colors within one named color category are more similar than across the color categories. But if you are really just using two colors, maybe what you want to do is emphasize the diverging nature of your visualization, which is what we have here. In this case, I want to show the diverging nature of these negative temperatures and positive temperatures. I'm not going to do this. I'm instead going to use one of these diverging color scales. Let's try this one. So here's a diverging color scale. It is highlighting the difference between the positive values and the negative values, but it's doing it in the wrong order. I actually want the negative values to be blue and the positive ones to be red. So we can very easily add a reverse encoding to this. We simply add reverse true, and it flips the directionality of the scale. So now we have the positive in red, negative in blue. Now, if I wanted to rely solely on the defaults and not make any more types of customization, this is probably what I would choose. This is closest to what my intentions are. Another option might be simply to go red to blue with white in the middle. Pretty much the same effect, depends on if you want white to be the middle point or not. Now this should draw your attention to something interesting about this, where when we're using these defaults, the defaults evenly space these values, where we have an equal proportion represented by red and an equal proportion represented by blue. That is normally very good for a default. That means that they have created the vast majority of the defaults to be perceptually continuous, which is excellent, meaning that each named color category represents the same visual portion of our scale. It's not necessarily what we want here because we have an inherent 0 that isn't halfway between our data. What we'd actually want is the red to go up here and stop at 0 and the blue to start at these negative values. So now we're at a point where we need to do something custom to modify the scale. The way we would do that is we need to specify both a domain and a range. The domain pertains to the data. This is the data values that we'll be representing, and the range pertains to the encoding that we'll be using. Okay, so for the domain, what we're going to specify is where we want the values that we specify in our range to be located on our scale. So I want it to start with -1, and then we'll do 0 for the midpoint because we're now specifying the midpoint, and we'll pick one of our highest values, which is 0.8. And then for the range, this is where we specify what colors we want to be mapped onto this. I've already looked these up, but you can look up hexadecimal codes in a lot of different ways. You can actually use words too. So if you wanted to write simply blue here, you could, but I know the specific color I'm looking for. In the previous video, I discussed how to specify naming conventions for color. The center point, I want that to be white, which I know is FFFFF, 6 of those. And then the last color, I want to be a deep red. So if we do that, that's better. We can now see that we have this midpoint here at 0. So we have red up until 0 and then blue. That's a little bit better than what we had before. But something I want to point out, and this in part has to do with color theory, is what Vega-Lite is doing is an interpolation. So it is going to interpolate from 1 to 0 and interpolate the values from this to this. And then from 0 to 1.8, it's going to interpolate the value from here to here. So what you're seeing is kind of a smooth gradient from white to this red and then from white to blue, which makes it so that all of these internal colors are interpolated between white and this other color. So you see a great deal of white kind of infecting this color here. And that could be what you want. Maybe that's fine. I really want to make this kind of poppy, and I want it to be very red for everything on top, not this kind of like sad white red, and same for the blue. So that's actually a little challenging to do in Vega-Lite, and I think the easiest way is sort of a hacky version of that. But what I'm going to define is more individual colors. So what I'm going to do is I'm going to leave white in the center, but I'm also going to specify the value very close to white. I want that to be -0.005. And then on the other side, I want to specify a value of 0.005. And I'm going to make this a light blue and a light red so that it basically shrinks the distance around this white here. All right, so what I've done here, maybe a little garish, maybe it's a little too much, but the goal here was really to have a kind of a pink that fades into red and a light blue that fades into red and then white at the center. And you can, mess around with these colors. Maybe you can make a version that is less garish than this. But my goal here was really to focus on the point that there is a flip around here where you go from these abnormally low temperatures and then you switch to abnormally high temperatures. And we're getting lots of very high abnormally high temperatures here in these more recent years. Now, I hope you can make more interesting versions using these different color scales. The real goal here is to ensure that all of the colors that you're using are discriminable. You want to be very sensitive to issues where colors are right next to each other and they might be perceived differently. You want to be sensitive to the different named color categories so that they make sense in accordance with your data. And once you've taken care of all of those, then you just want to make sure that the chart is aesthetically pleasing and interesting to you. This might not be the best solution. Maybe you can come up with more interesting ones, but I think this really highlights my main message that I'm trying to get across. That's it for a deep dive into color. Stay tuned for more videos on visualization in Vega-Lite.